Hi, my name is Manish Gupta, and in this video, I'm going to talk about Olmo OCR 2. So let's get started. What is Olmo OCR 2? It's the best English OCR for digitized print documents like PDFs. So I'll talk more about the results and comparisons with other models, other OCR models in the next few slides. But the idea is it is like right now the best English OCR for digitized print documents. It specifically works really well for math formula conversion, table parsing, and multi-column layouts, which have been traditionally very complex for OCR kind of tools. Right? So Olmo OCR2 is actually it's supported by this VLM, Olmo OCR2 7 billion. So it's a 7 billion parameter visual language model, and it's basically it's basically released very recently. So it's October 2025, right? And it is trained using reinforcement learning, specifically using the GRPO policy optimization with verifiable rewards. So that's also called as RLVR. So that's that. Now, for the reinforcement learning, they basically make use of binary unit test based rewards rather than edit distance based rewards. So when typically people are, training something for OCR, they typically use edit distance based rewards. But these authors sort of claim that edit distance is actually a wrong measure of how well the OCR is performing. And to support that claim, they basically, show these two interesting examples. So why binary unit tests are actually rather better compared to edit distance. Okay. So look at this. So this is the original equation. This is the scanned image, right? So this is basically the original equation. And this is the reference LaTeX. So basically, just to tell that this is basically the reference LaTeX that was available. So this is the golden ground truth effectively, right? Now, model A basically gave these results, model B gave these results. So model A and the reference actually differ a lot. I mean, not because they're semantically different, but because they are syntactically different. For example, model A has those braces. Now, in LaTeX, if you understand LaTeX, those braces don't matter really. I mean, especially if there is only a single character inside, right? So basically, model A and reference LaTeX have an edit distance of 37.84, while model B and reference LaTeX have a very small edit distance, 9.33. But actually, if you look at it, when you try to render, well, model A is rendered, LaTeX, when it is rendered, it basically is exactly the same as the original equation. While model B's LaTeX, if you try to render, it's basically incorrect. You see this overline, this is the overline and not really the bar that is expected in the original equation itself. Okay. So edit distance, although this one basically has a higher edit distance, but still it is better compared to the second model B's output, which has a lower edit distance, but it is worse. Okay. This is another example. So you look at this image, right? I mean, there is some picture here. The idea is not to look at what the picture is, right? This is just a sample PDF. So basically, there's some picture here, there is some text here, and the reading order. I mean, if so, this particular test is about reading order, right? So if you really look at the reading order test, so a human could basically read it like this column first and then that column and then look at the picture. Or the human could look at the picture and then read this column and then that column. So, if you basically consider these three things, the red box, the green box, and the yellow box, well, the first two rows, basically both of them are good in that census. Both of them are very reasonable in that census. But if you're using edit distance, well, you would end up by choosing, you would want to choose only one of them as correct. Now, which basically means that you would end up choosing the first one is correct. But what about the second one? Second one is also equally correct, right? So basically, the idea is that they realize that binary unit tests are basically better compared to edit distance based method for training their reinforcement learning based, doing their reinforcement learning based training, right? They use several kinds of binary unit tests. So for example, they check if a particular piece of text is present or not, or if a particular piece of text is absent or not. The natural reading order. So check sentences for their reading order correctness, table accuracy. So they also parse tables. So therefore, they check the relative position of cells in a table, or math formula accuracy. They check that a given math formula visually renders the same way with Kartik. Kartik is basically similar to LaTeX in that sense. Right? Baseline, so they also check that long repeated n-grams or non-target language characters do not appear, right? So because many times these models actually hallucinate and they keep repeating the n-grams, so they also check for that. Okay. Now, how do they basically generate the data to be able to train this model? So the model is trained using two different kinds of data sets. One, which is basically these unit test supporting data sets. So if you have to basically support these binary unit tests binary unit tests to define the rewards for reinforcement learning, you need a data set around that, right? So they do this creation, at a cost of like 12 cents per page, because to do this unit test creation, they actually use Claude Sonnet 4 API. And that is where basically this cost is involved. So essentially, we'll talk about the details about how this dataset is created, but the dataset is called Olmo OCR2 Synth Mix 1025, October 25, and it has about 2,186 PDF pages with about 30,000 test cases in it. Okay. So the way these test cases are generated, or the dataset is generated, let's look at that. So they take documents with diverse and challenging layouts. Specifically, for example, you could take archive documents which are math heavy, right? They render it in HTML using Claude Sonnet 4. So Claude Sonnet 4 is a very large model, so you assume that does a very good job. And they actually prompt Claude Sonnet 4 in three different steps. So in the first step, they just prompt the model. They give the original image of a page in the PDF, and they basically ask the model to identify general page layout. So just identify the number of columns, whether images or tables are present in it or not, headers and footers are present in it or not. Okay, that's the standard metadata is basically what is being asked by them for the model, for the particular page from the model, right? In second step, you basically take the layout output that the model provided along with the original image, document image, and then give this prompt, render this document as clean semantic HTML. This is the main step that basically generates the HTML, right? And then in the third step, you try to refine the HTML by giving the original image. You give the original document image, but you also take this HTML and render it. So you get the image from the rendered HTML, and then you pass on this actual HTML, which was generated in step 2, right? And then you give this prompt, refine HTML to better match with the original. Okay. So it's a 3-step prompting that they basically use to generate synthetic data, which basically comprise of the original document image and a rendered HTML equivalent, along with the layout information. So all the metadata information in that sense. Okay. Now, based on that, they extract verifiable unit test cases depending on the semantics of the HTML. So the HTML basically contained a header. You could basically ask, whether a header is present or not, or and so on. So various kinds of such unit test cases. Okay. So that's the first data set comprising of 30,381 test cases, right? The second data set that they basically use is OCR, Olmo OCR Mix 1025, October 25. This data set has been created using GPT 4.1. So this data set basically is not used for reinforcement learning. It's a standard supervised fine-tuning based data set, and just contains basically the original PDF image along with the rendered HTML as generated by GPT 4.1. Okay. It's a larger data set. So on 100K PDFs, they extracted 268K pages, and for each of them, they actually have HTML formatted output, including HTML format for tables and alt text for images. So that's the input output pairs they have, and they basically use it for supervised fine tuning. So the interesting part about this Olmo OCR2 model is that weights, training data, training code, inference code, all of them are publicly available under Apache 2.0 license. Right? So how is the training performed? Well, there are these two data sets, but how is the training done? Well, the training is done by starting from Qwen 2.5 VL 7 billion instruct model. So that's the 7 billion parameter model that they start from. And in the first step, it is supervised fine-tuned on this Olmo OCR Mix October 25 data set. Right? Second step is to do reinforcement learning, RLVR, reinforcement learning with verifiable rewards. So for that, they basically make use of this Olmo OCR2 Synth Mix October 25 data set. The way they do reinforcement learning is to basically take each of the documents in this data set, and for each of them generate like 28 completions from your model, which is supervised fine-tuned, stage 1 model here, supervised fine-tuned model, right? And then you compute the reward. So as a fraction of passing test cases. So remember, these are verifiable these are directly verifiable because these are like unit test cases which have been automatically created in this pipeline, right? So therefore, you basically define the reward for each of those completions as a fraction of passing test cases, and depending on the reward, you perform GRPO to update the policy and so on, right? So besides these unit test cases kind of rewards, they have 2 more rewards. One of them checks whether the completion ends with the end of sequence token or not, And the second one checks if the model outputs document metadata also at the top of its response. So they want to ensure that the model actually outputs document metadata also, like primary language, whether it is English or not, and then rotation correction factors. So if the document really requires some rotation and so on. Yeah. So using this method, this two-stage method, the first stage being supervised fine-tuning and the second stage being reinforcement learning, using this two-stage method, they actually train 6 different models with different random seeds. And then they do a swooping of the weights and ensembling of the weights of the models so as to get their final Olmo OCR2 model. Right? They work at a pixel resolution of 1288, and the model outputs YAML. So rather than outputting JSON, they found that YAML is much more stable from a clean output perspective. Now, how does Olmo OCR2 perform? Well, as I mentioned earlier, it is a state-of-the-art model for English printed text OCR. So as you can see, this is basically being compared with several other OCR models that you see here, including DeepSeek OCR, which I talked about a few days ago. Right? Many of these models have been proposed very recently. So as you can see, most of them have been proposed in 2025. They have come up in 2025, and Olmo OCR2 is like 82.4. Which is which is basically almost at the top, except for these two guys, which basically, do not have their training code or training data publicly available. But, if you look at it, it is basically Olmo OCR2 is basically one of the best models right now with openly available training data, training code, inference code, model checkpoints, all available under Apache 2.0 license. Okay? Here are two examples of how the model performs. This is handwritten text, and actually you can see, it does not perform poorly even on that. So it actually does a very good job. So February flow, it's basically getting those things very nicely. Data components, code, the stack v2, code text SE, whatever we have script. I mean, if you read through the text, you can pause the video and read through the text, and you can basically appreciate that actually is able to extract most of the stuff here very accurately, even though it's handwritten. This is a basically very old document from the some American archives, and as you can observe, even this text is actually very accurately OCR'd in that sense, even though it's sort of slightly blurred and so on. Yeah. So in summary, in this video, I talked about Olmo OCR2, which is basically state-of-the-art OCR model on Olmo OCR bench. So this comparison that I showed here is on this benchmark called as Olmo OCR bench. Okay, which is human verified data. So that's that. The main interesting novelty in this model is reinforcement learning with verifiable rewards, which basically makes use of binary unit test rewards rather than edit distance based rewards. And these binary unit tests basically are generated in a verifiable manner using auto-generated data. So as we discussed here, right? That's it for this video. Hope you liked the video. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.